This video shows how the island of Mauritius has changed over the past 250 years and what those changes mean for the long-term survival of species like the pink pigeon. In 1773, Mauritius was almost entirely covered by native forest. As the animation progresses, you can see the green forest patches shrink and fragment as the island is cleared for farming, timber, and settlement. By the early 1900s, around 3/4 of the native forest had vanished. Today, less than 3% remains. Each red dot represents an individual bird in a simulated population. As habitat disappears, they become isolated in tiny pockets of forest, exactly what happened in real life when the pink pigeon was reduced to just 10 surviving individuals in the wild. This simulation shows the genetic consequences of this habitat loss. Each bird is modeled with its own genome, carrying a mixture of neutral and harmful mutations. As the population shrinks and fragments, genetic drift and inbreeding start to cause genomic erosion. At first, these genetic changes are invisible. Even after a century of habitat loss, the population still appears genetically healthy. But over time, harmful mutations slowly increase their frequency, reducing survival and the overall resilience of population. This delayed genomic erosion is called drift debt. In simple terms, the genetic consequences of past habitat loss only become apparent long after the damage has occurred. Even if we stop cutting forests, the genetic problems continue to accumulate. This has major implications for conservation. The pink pigeon has been downlisted on the IUCN Red List from critically endangered to vulnerable. However, although its numbers have increased to over 500 birds, our genomic studies show that its genetic diversity is still declining and its genetic load remains high. Traditional Red List criteria don't capture these long-term genetic threats. Simulations like this show that saving species isn't just about stopping population decline. It is about restoring genetic diversity alongside habitat. We are therefore reintroducing pink pigeons from UK zoos into the Mauritius population. Excitingly, we are also exploring if we can recover some of this lost variation through gene editing, using DNA from museum samples.